Hello, Assalamualaikum. We are from Group 5. My name is Nahimudin Ibrahim bin Hyder Ali from Group 5, and my team members Nasrul Daniel and Syamsul Nizam. So, our group are going to present for our Aero Lab 3 under Dr. Salah. Our experiment is comparative analysis of theoretical and fine force measure gravitational acceleration.
First part is the background. So our background project is the gravitational acceleration G is one of the most fundamental physical constant using in engineering and physics. The theoretical value of gravitational acceleration varies slightly with altitude and geographical location. Right now, modern smartphones use equipped with an accelerometer together with applications such as phypox that allow gravity measurement without expensive laboratory equipment. This experiment compared the theoretical gravitational acceleration with measurement obtained using smartphone to evaluate their accuracy. So next one is the objective. So our group objective is to first to determine the theoretical gravitational acceleration at different location using the elevation data. Next, to measure the gravitational acceleration using the 5-foot application. Third, to compare theoretical and experimental value. Next one is to determine the percentage error of each measured device. And lastly, to evaluate the reliability of smartphone sensor for gravitational measurement.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syamsul and I will present the methodology for our experiment. So before we start collecting our data, we first determine the altitude of each experimental location by using Google Earth. So from this altitude, we use theoretical formula to find the actual gravitational acceleration for each site, which we will use as our baseline on this experiment. And during we conduct the experiment, we place our device on a complete flat surface to ensure there is no external movement was captured by the device. This step was conducted to ensure the potential of the noise potential and error will be reduced in our data. And we also conduct 5 separate trials for each location or attitude to make sure the data is reliable and accurate. And we log each set for 1 minute. And then after we collect all the data, we average all the trial to get our final value. And lastly, we calculate the percentage difference by compare our actual gravitational acceleration and the measured data from each device. Now we present the comparison data that we obtained from two different devices that we use to measure the gravitational acceleration across 5 different altitudes. So first, if we look at the line graph on the right, we can see that C5P are consistent in overestimate the gravity, and the trend is also almost similar with the actual gravitational trend. However, for device A, we can see that the trend is quite weird, which is it have upward slope across the entire experiment, which we can see from the 58 meter. The gravitational is rising from 9.75 meter per square up to its peak at 9.771 meter per square at 1,642 meter. And when it comes to the final altitude, which is 1,685 meter, the river has a reverse trend and follow the actual gravitational trend. And next, if we look at the percentage difference, we can see that the device B has a consistent lower percentage error, and we can see the range is between 0.974% and 0.3522%. And if we compare to device A, it shows a higher error between 0.2649% and 0.512%. And this demonstrates that device B are better in accuracy and consistent to measure the gravitational acceleration, and it also can be a conclusion that the accuracy of the measurement are heavily depend on the device that we use to measure, where it depends on the specific hardware limitation and calibration of the device that being used.
In conclusion, our experimental measurement value closely match with our theoretical gravitational acceleration. Hence, phypox successfully measured our gravitational acceleration using smartphone experimental. However, since we're using two devices, device B shows more accuracy than device A. This shows that we need to use multiple devices for this experiment to get a more reliable measurement. And finally, smartphone-based experiment offer a low-cost alternative to traditional laboratory equipment since everybody have a phone, everybody can install Firefox, and everybody can do a simple experiment.